Okay, here we're going to go through and follow up on practice problem number 30. So this is where we ended in the last lecture. So now we've got a pretty good grip on how to do hypotheses. Then we're going to move on to looking at the testing procedure for testing these hypotheses. So this is going to be a kind of lengthy video to follow us all the way through from beginning to end for doing the p-value method. And then the next video is going to look at the critical value method. As I said, both of these videos are kind of going to be long because we need to go through from beginning to end all the way through. So feel free to stop it partway through and take a break if you need to. So here we have our hypotheses in terms of our formulas. And the next step you can see in your figure is going to be selecting a significance level. Now that's actually what we do when we design a study. Here, what we're going to be doing, because we're extrapolating from a study we already have, we need to identify the specified alpha level. So looking at this particular problem here, what is going to be the alpha level that I'm given to solve for this problem? What is the goal here in terms of my alpha level? My alpha level is going to be 0.05 because it's given as my significance level. So significance level is the same thing as alpha. And make sure you've got that written into your notes so that you can translate that correctly. If you got a significance level of 0.05, then you're going to have an alpha of 0.05. So our next step is identifying the relevant test statistic. And to do this, we're going to use the table 8-2 on page 381. So let's go take a look at that now. Now I've cut and made a copy of this into this PowerPoint, but I suggest that you get a copy of this from your text and put it in your notes as well so you can use it. Here we can see that we're going to match up the language from the problem to help us determine what is the relevant test statistic that we're solving for. So here we're being asked to solve for proportion. So looking at this table, we can see that if I'm solving for the parameter of a proportion, and I've got my sampling distribution is a normal z distribution, right? So and I've told that my z-score is one standard deviation above the mean of 0, so that means it is a normal z distribution. Then that means I'm going to be solving for a z value. Now we'll get to computing the actual test statistic value in a few minutes, but here it's enough to know that we're solving for a z. Remember, this is really important to make sure you're using the right distribution table. Okay, so now we have our relevant test statistic of z. And now we need to decide if we're going to use the p-value method or the critical value method. Now both the homework and the exams, sometimes it asks you to solve one approach or sometimes the other approach. Often it asks you to solve both. I suggest, even when it's only asking you to use one method, such as the p-value method, I suggest you also still solve it for the critical value method, simply because you can use them to check your work. If one of them gives you one result, in terms of rejecting the null, and the other one gives you a different result, then you know you've done something wrong, and you need to go back and check your work before you submit the answer on that assignment. So working through the p-value method, the next step we need to do is find our test statistic. And here, looking at this, we can see we've already been given our test statistics. So notice they say the sample statistic results in a z-score that is one standard deviation above 0. So we've got z equals 1 here. And now I need to find the correct p-value for this. So what is going to be the corresponding p-value? And to do this, we're going to use figure 8-4 on page 383. Now, this is an incredibly useful figure. I suggest that you print this out and put this in your notes so that you can use it both for solving the homeworks and also then, of course, on the exam. So let's go through this step by step when we're looking at this. So here we see when we start off, the first thing we need to do is decide what type of test we have. Do we have a left-tailed test, a two-tailed test, or a right-tailed test? And in order to make that assessment, we need to look at our alternative hypothesis to determine which type of tail the problem is requiring us to solve for. So looking back here at these figures, we can see, and these figures over on the left-hand side of your text as well, again, I suggest you include them in your notes, print them out and put them in your notes. We can see here that if a sign is the symbol of not equal to is in my alternative hypothesis, then that indicates that I'm doing a two-tailed test. If the symbol is a less than, that indicates I'm doing a left tail, one tail test. So I've got a one tail test and it's to the left. If it's greater than, that means I'm doing a one tail test and it's going to be to the right. And so if we look here, we can see if we're using the hypothesis, if we're looking for a difference between, we're doing a two-tail test. and we follow that arrow down. If we're having a less than in our alternative hypothesis, then we follow the left-tailed direction. And here, if we're looking at it, then we're looking at a one-tailed right-tailed, then we follow in this direction. So combining these figures here on the left with this flow chart here on the right should help you make the decision about finding your p-value accurately and correctly. This is a critical part of solving the problem, so you need to make sure that you are using these materials to help you accurately make your assessment of what p-value you are solving for. So, looking back at our sample problem, we're going to look at our alternative hypothesis, and here we see that our symbol is not equal to. So coming back and applying, we can see that we are going to be doing a two-tailed test. So we now know we're doing a two-tailed test for finding our p-value. The question we need to ask is the test statistic to the right or the left of center? So if we're looking at this, keeping in mind we're using a z-distribution, so its mean is going to be equal to 0, right? That's the mean, and we know that our z-value is 1. Is that 1 going to be to the right of the 0, or is it going to be to the left of the 0 if we graphed it out? Well, it will be to the right. So if we had, for example, a -2, then it would have been to the left. But here we have a z of 1, so that means that we're going to be solving this problem to the right, which brings us down to this bottom part where we're going to be calculating our p-value, and it gives us the caution here that our p-value is going to be twice the area to the right of the test statistic, okay? That's because if we look at the two-tailed, notice it's split in half, right? So if I'm going to be using just the z-distribution, I'm going to have to put those two areas together. So let's go back and look at this step by step, because that can be a little bit confusing. First up, just looking at it in terms of language, but let's follow through the problem. So here we know we have my p-value, we know z equals 1, so I go and I locate my z-distribution in the table, right? And I find that I'm looking at 1.00 is my z, and so I locate the associated probability in the table as being 0.8413. However, remember the z-distribution sums from the left, while the z-score, the value I'm interested in is the value to the right. So I'm going to have to take 1 minus 0.8413, and that's going to give me 0.1587 for my probability. But we're not quite done yet. Remember, looking back at our figure, our p-value has to be twice the area to the right of the test statistic. So I'm going to have to take that value and multiply it by 2. So that's going to give me, my final p-value here is going to be 0.3174. Now, take your time with these and make sure you understand how this is put together and solved, and make sure especially that you're leaving very detailed notes so you can be able to follow your course and for what you're going to be doing. This is a really easy place to get confused when you're doing the homeworks and on the exams, so make sure you're leaving a detailed record for yourself of how to solve these problems step by step. Okay, so now I've got a p-value of 0.3174. All right, so now I'm on to step number 8. Step number 8, and we're almost here. Now we're getting ready to do our comparisons and interpretation. So here I'm looking at comparing my p-value to my alpha. So I've got my p-value of 0.3174, and we've got my alpha. We've already decided the alpha that I'm using as my comparison is 0.05. So we're going to plug these in, and we're going to get the p-value 0.3174. And we're comparing it to 0.05, and here I've put in terms of a math problem, so we have to answer, is this a true statement? So is it true that 0.3174 is less than or equal to 0.05? If that is a true statement, then where the answer to that is yes, that is a true statement, then we would reject the null hypothesis. If in fact it is not a true statement, then we fail to reject the null. So looking at this problem, are we going to reject the null, or are we going to fail to reject the null? We're going to fail to reject the null. So here we can see our p-value is not less than or equal to 0.05, so we fail to reject the null. Now we need to restate our decision in non-technical terms to address the original claim, and to help us do that, we're going to go through and use table 8-3. Or you can also use this flow chart here. I actually like the flow chart better. The table is more succinct once you're sure what you're doing. However, when you're first learning, I find that the flow chart is much easier. So looking at this flow chart and going, does the original claim contain a condition of equality? Yes, it does. So we're going to move over. Did we reject the null? No, we did not reject the null. So when we're looking at comparing it to our information here, we're going to say there is not sufficient evidence to warrant rejection of the claim that the proportion of girls born to parents using XORT will be equal to 0.50. So the null currently stands, all right? And that would show then that the XORT method, there's currently not evidence supporting its claim. Right? So that is the final statement. When we take that and we put it back over with our hypothesis problem that we've been asked to solve, there is not sufficient evidence with this sample to indicate that XORT increases the chance of having a baby girl. And this concludes this video on using the p-value approach. The next video will go over using the critical value approach for solving the problem.